Hey Math 1B in Geometry, I've got a new lesson for you, 2.7. It's actually not really a new lesson. What we're doing is we're looking at systems of equations and asking ourselves, would it be more convenient to use substitution or to use elimination? So, let's get to it. I only got 3 examples. Here's our first one. You've got x plus 2y equals negative 9 and y equals negative 3x minus 7. Now, right off the bat, I'm recognizing that y is already by itself, which seems like maybe substitution's probably our best bet in this case, because the first step for substitution is to get x or y by itself. So in this case, I'm going to roll with sub and say that step 1 is going to be, well, get y by itself. It's already done. Y equals negative 3x minus 7. And I put that in parentheses, if you recall. All right. Then what we did was we said, take the equation that you didn't get x or y by itself, which would be this top one right here. So this would be step 2. Take x plus 2y equals negative 9, and then say that blue y is going to go right here. Which means I can replace the blue y with the negative 3x minus 7 parentheses variable expression. So I'm going to rewrite this. The y is going to completely disappear and be replaced with negative 3x minus 7. All right, at this point, I'm just going to get rid of parentheses and solve for x. I'll do that in a different color. So you're taking the positive 2 times negative 3x. You're getting minus 6x out of that. You're going to take positive 2 times negative 7. You're going to get minus 14 out of that. These two can just drop down. The x wasn't multiplied through. The negative 9 was just chilling on the right-hand side of the equation. And then at this point, you're just combining like terms. So it's like I've got a 1x minus 6x, which would give me negative 5x. Minus 14 is equal to negative 9. I can add 14 to both sides, which gives me negative 5x. This cancels. Opposites subtract, so 14 minus 9 is 5. Take the sign of the bigger number, which is 14. So it's going to be a positive 5. Then you're going to divide both sides by negative 5. You're always dividing by the number in front of x. That cancels that out. You're left with x equals negative 1. Okay, I got my x term. So it's going to be negative 1 comma something. Now, that something can most easily be gotten by taking what you had here and plugging it into this equation right here, because y is already by itself. So if y is already by itself and I'm trying to solve for y, stands to reason that I should, on step 3, take y equals negative 3x minus 7 and replace this blue x with the black x down there, which is negative 1. So then negative 3 times negative 1 is 3. Minus 7. Y equals negative 4. So this is technically step 4 where you wrote it as an ordered pair, where you write it as an ordered pair. But yeah, that's a nice little, hey, that's how you do substitution reminder. Let's try number 2. So you've got 2 equations in which x are already by themselves. I think this one's a good substitution one again. During the substitution sections, we had ones where y was by itself, so we just set the two parts equal to each other. It's kind of like saying, step one again is done for us. So all I do is say, if x equals 4y plus 5 and x equals 3y minus 2, I then can set them equal to each other. I can say, take this x out and replace it with a blue x, the 4y plus 5. So sorry, my explanation there was kind of muddy. Basically, when they both equal a variable, and it's got to be the same variable, they both equal x's, then you can set the right-hand sides equal to each other. And then I can solve for y. Now just remember, if they're separated by an equal sign, you have to do the opposite operation to get them together. So you should be thinking, hey, I have a positive 3y, move it to the left with subtraction. Okay? That gives you 1y minus 5 is equal to negative 2. If it's minus 5, you're going to move it to the other side using addition. So 1y is equal to 3. And if 1y equals 3, then y equals 3. I mean, you can divide both sides by 1 if you want to, but dividing by 1 doesn't change the number. All right, I've got the right coordinate. Now I just got to solve for the x coordinate. I got two options. Pick one and go with it. I'm going to pick the bottom one. So step 3 is I'm taking x equals 3y minus 2, and I'm saying we want the blue y to go in place of the black y. So then x equals 3 times 3 minus 2. That gives us 9 minus 2, which is 7. All right, so my x-coordinate is 7. So my answer is 7, 3. Let's try one more. Let's see here. There we go. Now I think this one really can be either method. Because if we wanted to use substitution, we could add 3y to both sides to get x by itself. But just to show you guys that elimination is still the thing that we're doing, I'm going to use elimination on this because the like terms are stacked. X is stacked with x's, y is stacked with y's. The equal signs are stacked and the constants are stacked on the opposite sides. So if we were going to use elimination, the goal is to create either the same x or the same y, where one's a plus and one's a minus. So in this case, I'm going to choose the y's, all right? And I want a negative 3y and a positive 3y situation. So I've already got the negative 3y. I'm going to multiply the bottom by positive 3 to create a positive 3y in that y spot. So I'm going to take 3 times 3x, which is 9x. I'm going to take 3 times positive y, which is positive 3y. equals 3 times 7. The top remains unchanged. So that's your first step to elimination. You're trying to get the same number. Oh, it's almost like a good twin, bad twin situation. We want that whole y term to completely cancel out. So negative 3 plus 3 is 0. We zeroed out the y's, which means we then add the other columns, because I added this column. Okay. So x plus 9x. 1x plus 9x is 10x. 0 plus 21 is 21. Divide both sides by 10. X equals, well, did you guys know that dividing anything by 10 just means moving the decimal place 1 to the left? So 21 divided by 10 is 2.1. So unfortunately we got a decimal final answer, but it's not too bad of a decimal. So 2.1, that means that our answer is going to be 2.1 comma something. All right, so at this point, we take our x value. This is kind of like step 1 and step 2 at the same time. You're going to pick one of the originals. X minus 3y equals 0, or 3x plus y equals 7 to plug in the 2.1. I don't know, this seems like it's going to be an easy calculation. I'm going to plug it into x minus 3y equals 0. And I'm plugging a blue x in for the black x, which is 2.1. So my goal is to get the y by itself, so I need the blue 2.1 to be on the opposite side of the black minus 3y. So I can subtract the 2.1 from both sides. Okay, negative 3y equals negative 2.1. And then divide by negative 3. Now, quick crash course in decimal division. Well, first of all, a negative divided by a negative is a positive value. And then, just recognize that you can move the decimal place over one time on both the top and the bottom part of that fraction, because you can multiply the top by 10 and the bottom by 10. So this is the same as 21 over 30. The only reason why I would say that is because 21 over 30, they both divide 7. I'm sorry, they don't both divide 7. They both divide 3. It's the same as 7/10. Or, since we started with decimals, maybe we should just call it 0.7. So, y equals 0.7. And there's my final answer, 2.1, 0.7. So, I hope you guys found this video helpful. Really, I'm just wanting you to piece together substitution, elimination. You can use one approach always. You can use the other approach always. But make sure you know at least how to do one of them. And yeah, that's all I got.